Hi, my name is Kevin Nilsson, and I'm one of the organizers of the Silicon Valley Google Technology User Group. And we're really excited tonight to have James Gosling come and present at the group. Well, I think what's really unique about this event is, James has spoke all over the world, but this is one of the first kind of opportunities for James outside of Oracle, not working for Sun, not working for Oracle, out to speak his mind, speak about whatever he's passionate about, and really nothing holding him back from what he says.
I'm Van Riper. Kevin Nilsson and we run the Silicon Valley Web Jug. We've been running it since 2003. Been meeting here for the last couple of years at Google. I actually was on the street walking to the Thirsty Bear during Java 1, and I saw James, and so I pounced. I'm glad we're going to have him here tonight. I know people are very interested to hear what he has to say about Java and the future of Java. I am curious to hear James's perspective on, the whole Apache, Oracle and the JCP, and Oracle and Google with Android, and I mean he's stated some of his opinions about it, but it'll be interesting to see what his current views are on that tonight.
I'm really happy to be here. I'd like to start, I suppose, with an apology. I was supposed to be here a month ago, and I'm actually supposed to be at DevOps right now, but I had this little surprise. I had to have 4 chunks of titanium taken out of my skull, and so when they asked me, it's just well, what do you want me to talk about? And it's I don't know. So I have no particular axe to grind, no technology to push, nothing to sell, nothing, So I didn't have any topics. So this is Q&A. So do you guys have questions? Otherwise, we're going home right now. All right, general sort of future of Java and where things are headed. It's really kind of hard to know. I mean, Oracle is a very strange beast. I will try to avoid ranting. But they have surprised me lately. They seem to have actually made peace with IBM, and they seem to have actually made peace with Apple, both of which were somewhat odd. Oracle clearly has a very strong incentive to not screw things up on this one, because the really huge fraction of all of their systems are Java based. All of their high growth systems are all Java based. So if they hurt anybody, it's going to be themselves. So they have a real sort of strong sort of self-interest in there. But there are all kinds of weird parts of the Java ecosystem that's hard to know exactly where they're going. I mean, what is Oracle going to do with smart cards? I don't know. What are they going to do with cell phones? I don't know. What are they going to do with any of their embedded stuff? I don't know. One of the things that's sort of odd with the whole Oracle transition was that they really didn't know what they had bought. They kind of understand databases, and then they understand things that live in the enterprise data center that are attached to databases, and everything else is a mystery. And so they're, it's like a learning process. And so I'm actually cautiously optimistic that they will do a fairly decent job. They seem to be saying all the right things about OpenJDK. So I'm feeling like yeah, it's actually a pretty bright future. Some of the pieces that I was working on, like all the embedded real-time stuff, that one's who knows? I mean, they have no idea what that stuff is all about. And one of the big problems that Oracle has is that it's an extremely hierarchical company, and there are really only 2 people at Oracle that are allowed to make decisions. Larry and Safra. Larry makes all the product decisions, Safra makes everything else. And so every decision about every piece of product strategy at some level has to go to Larry. And they've done all of these acquisitions, and he's only one guy, and he's not real good at delegating. And he's got finite bandwidth and almost an infinite number of decisions to make. And so it becomes a really plodding sort of thing. The question is about, multi-core, what can we do about it? What's the right thing to do with Java? And that's a really fascinating issue. And it feels like there's an unbounded supply of PhD thesis topics in there. And one of the things that's hard about that is that it's been a really rich source of PhD thesis topics for about 30 years. And, as near as anybody can tell, Moore's Law is actually carrying on just fine. It's probably got like another 20, 30 years of gas in it before things really break down. But what's broken down is the ability to turn transistors into clock rate. And yet, if you take core count times clock rate, that's been pretty much a straight line in log space. And so what does it mean, right, when the core count is exponential, right? You go 20 years in the future, that's a factor of 1,000-ish in core count. So the top of the line desktop processor these days is about 6 cores. What are you going to do with 6,000 cores on the desktop?
Program them effectively.
Well, how are you going to program them effectively? And, probably the answer about what you're going to do with them is, model blood droplets in Duke Nukem 37. And the problem with multi-threading is that it's extremely sensitive to the domain. So for instance, in most enterprise situations, Java actually works pretty well kind of out of the box. I mean, Sun made machines with 200 and some odd processors. It was like 240 something or other. And if you look at what happens with things like Java EE, Java EE sort of abstracts away all the multi-threading, all the ugly issues happen, underneath the floor, and things scale remarkably well in that universe. Java at least has threading and locks built into the language from the very, very beginning, and the concurrence is pretty darn good. And if you follow the standard patterns in the concurrency library, a lot of concurrency can be pretty easy. And then there are domains where concurrency is also easy, but they're not handled by existing frameworks, right? So for instance, graphics rendering, things like ray tracing and such. Those guys, that parallelizes almost trivially. Then it gets harder really, really fast. And there are all kinds of issues about, lock contention and threading and deadlock and the rest of it. And, there've been lots of attempts to do things like build compilers that automatically derive parallelism from programs. And mostly failed except for really tight domains, right? So for instance, automatic parallelization of Fortran code for matrix intensive stuff works moderately well. For almost anything else, doesn't really work at all.
Fortran was extended.
They both added extensions to Fortran for parallelism, but also a lot of people did
automatic parallelization compilers for sort of standard Fortran, because mostly what people wanted to parallelize in the Fortran world was stuff that had already been written. And one of the problems with most Fortran code is that A, it's doing something real important, and B, the person who wrote it is probably dead. Most of the Fortran shops out there, it's archaeology, not coding, right? And yet there are some really important pieces of Fortran code out there, like interplanetary navigation. Lots of people got PhD theses out of writing one 20-line Fortran function. And it's like one person in the entire history of the world understood that one Fortran function, and then they got hit by a bus, and so it's kept there, and they keep using it. But then once you get into like some of the functional languages, there's a whole lot of opportunity for because functional languages sort of they exist outside of time, right? There is no this, then this, then this in a functional language. And people have done all kinds of work to, analyze functional programs that way and do automatic decomposition in functional languages. And that's worked fairly well in, PhD thesis topics. Nobody's really pushed it very hard in practice. So like in Scala, it's got this sort of mixture of functional and not, which makes some of those efforts somewhat difficult. But they put most of their effort on parallelization, on libraries and the use of closures, as opposed to, actively taking your program as an algebraic structure and trying to do transformations on it. And there's a lot of territory there. I'm not expecting to be bored for a very long time. So the question was, Java was originally simple, added generics, and it's the sign of the devil. And I kind of agree and I kind of don't agree. Java started out as a very, very simple language, and one of my rules in the early days was that I didn't want to put in anything that I wasn't sure, hadn't been tried over and over and over again to be sure that there wasn't like a different way to do it. And one of the things about generics was that you wander around the world, you talk to language designers, 15 years ago, and they would all say, generics, really, really good idea. You've got to do it this way. But they all had a different version of this way. In fact, they usually had like two this ways. And, so there was no way to there was no agreement as to what was a good way to do generics. But, when evaluating the simplicity of a system, it isn't just, the programming language, but the systems that people write with it. And I know for me, it feels like there was a pretty significant simplification of the code that I wrote and an improvement in the compile time checking that I got out of the compiler. And it really felt to me, and still feels to me, like, while, yeah, generics added some complexity, they also removed a pile of complexity. And if you use generics properly, it feels like life got a whole lot better. Of course, part of the problem with generics was that in the beginning of the process, there was this strong rule. You had to be able to write the documentation for generics to a useful level on one sheet of paper, and that mostly works with the current generic system, right? And then corner cases in type theory kept getting discovered. And then all these funny quantifiers got added, and I don't know how to answer some of the questions about it. You'd have to get Neil Gafter in the room, and he could explain things, not me. The nice thing, though, is that most of those corner cases you can actually ignore most of the time. So I feel that the language itself has done pretty well. Where there's been most of the madness is not in the language, but it's been in the libraries. And the nice thing about the libraries is they're nicely compartmentalized. And the issue isn't so much that there's a bulk of them, but there's like 5 ways to do anything. And, you have to pick, which library of the 5 out there. And for some of them, it's way more than 5. For doing things like XML parsing, there's like, the world is drowning in XML parsers and JSON parsers. But then why would anybody use a JSON parsing library? Because it's only like a page of code. That's why I like JSONs. You can do a decent JSON parser in a page. But simplicity is kind of a relative thing. And I feel fairly good about the language part. And the VM design has actually survived pretty well. But yeah, it got popular. Other questions over there? When do I see closures coming to Java? Well, I had kind of hoped they'd be in for a while there, I kind of hoped that they would land in like JDK 6, but that got kind of weird. And then for a while, it looked like they would be in JDK 7, and now JDK 7 actually got pulled in, and so there's a decent chance that it will happen in JDK 8. But closures turned into a really ugly fight. And it got spectacular. It got into, kind of a social mess, and once upon a time, I was the only person who touched the Java compiler, and I was the only person who touched the Java runtime, and there were only like 10 engineers who wrote Java code, and if I wanted to change the language, I could like get up in the morning and go, go-to statements are really stupid. I'll just get rid of that, and I'll grep through all the source code in the world and delete go-to statements. And I actually did that one morning. There were 13 go-to statements in the entire universe. I rewrote their code for them, and the world has been a better place. When you've got, somewhere pushing 10 million professional Java developers in the world, the most obscure things turn into food fights. And that's kind of a good thing. It's kind of a bad thing. But, Oracle seems to be, pushing the JDK process. So I'm reasonably hopeful. The whole JDK 7 thing had gotten like really stuck. And of course, the major sticking point, or one of the major sticking points, had been Oracle. The other major sticking point on JDK 7 had been IBM, and that seems to be in the past now. So, but it only seems to be. Time will tell. What's my second favorite language? I don't know. It depends. I don't know how to even judge that. I've probably written, an ungodly amount of C code, but I hate C with a passion. I've been writing a lot of Objective-C code lately, which just sort of refuels my hatred for C. .h files are absolutely the work of the devil. I guess my second favorite language these days is probably Scala. Martin did a lot of things in Scala that I wish I could have done in Java. And of course, the problem with Java when I was doing it was that the goal then was to convince a bunch of C and C++ programmers that this weird thing that was more like small talk was actually something sort of comfortable that they could understand. But Yeah, I'm kind of omnivorous when it comes to languages. Give me, so long as it's got garbage collection and threading, I'm reasonably happy. So the question was about hardware implementations of JVM bytecodes. Yeah, that was always doomed from the beginning. And it's been proven. It's not like a Java thing. It's that. Yeah, you could build processors that had special instructions for Java bytecodes, but if you've got a decent compiler guy, which I count myself as one, taking Java bytecodes and compiling them down to instructions for random x86 architectures, random ARMs, random PowerPCs, random Sparks, is pretty easy. Right. I mean, the translating the bytecodes into pick your favorite CPU is really, really easy. And so then you get to the fact that designing a CPU is expensive. It's really expensive, right? So a random x86 CPU costs like a couple of $2 billion. So people have done Java chips, but they've only got a budget of so much, and they can only get so much performance because most of the performance isn't the instruction set. It's the caches, it's the floating point units, it's how you do instruction decoding and how much parallelism you can get in the register set, all kinds of things that have nothing to do with the instruction set. And so you take somebody like Intel who blows a couple of $1 billion on a new architecture, they can afford to optimize stuff that you can't even afford to think about. So people have built specialized architectures for they used to build Lisp machines, they used to build Pascal machines, and always what would happen was that they put out the first version of the Lisp machine. They'd get pretty good numbers, and then some compiler jock doing a little Lisp compiler would show that generic architecture and could crush it, right? And so the issues with a language like Java are not about the instruction set, because the compiler can do that pretty well. There are other issues like things that you could do to make garbage collection more efficient, like change the way that write barriers are done. And some folks have done chips which just have like special write barrier stuff, right? So the Azul guys did that. But then at some point the Azul guys figured out that doing custom silicon was dumb, because they figured out how to do all those tricks with page tables on a sort of a generic x86 architecture. So it's not so much that it doesn't work to do a specialized instruction set, but that it does work to do it on like a completely generic instruction set. And when you use a generic instruction set, you get to leverage off of the volume of that chip, and that somebody else is blowing the couple of $1 billion on it. And when you can compile down to things like ARMs as well as you can these days, and the Java JITs that compile down to ARM and x86 are just really, really sweet. And they're all nice processors. Well, Java runs. I mean, the smallest CPU I know of that runs Java is these guys, and that's pretty darn small. And it's been really, really successful in smart cards. The cell phone business had been really, really successful for Sun. And then the cell phone business has kind of turned into a food fight of spectacular proportions. And I'm sure glad I'm not in the middle of that right now. I get to just be an observer. And the Oracle guys, they're kind of confused. It's not a business that they've ever been a part of. Certainly Sun had been making a lot of money in that business. I doubt that Oracle will be doing the same. I was using Objective-C because, well, there's only one place in the world that Objective-C still lives. Somebody before this was asking me, well, why are you writing Objective-C code instead of Android code? It's like, well, Android code is like stuff I know already. And I figured I had to, because I had like read through, like I had done Objective-C coding like 20 years ago. And then, it's like, oh, Jesus. And then, decided a while ago that I'd better, try Xcode and see how it was. And I guess the depressing thing for me is that it's actually pretty bad. They actually finally added garbage collection, but it's kind of not very good garbage collection, and it's got all of the C problems with pointers causing, mystery meat crashes. And all the issues with header files, and they even made header files worse with their property declaration, so that you actually have to declare a field, you kind of have to write it down 3 times, right? Because you have to do the field declaration, you have to have the @property, and then you have to have the synthesize directive, all in different places, and you have to get them all right, and they have to agree with each other, And yet, people are doing a huge amount of Objective-C coding. And why? Well, because there's a financial reason for it. You can actually get a paycheck doing that. In the iPhone app world, it's a really bimodal world, right? You go through the App Store, and the vast majority of people who write iPhone apps, kind of makes nothing off of it. But there's a few home runs. And I have no idea what makes a home run in that world. And I don't even know what makes a home run for me. I mean, I don't understand why I find Fruit Ninja so compelling. Getting a good, fruit frenzy going is like, but, it's an interesting world. I haven't been really following Google's contributions to libraries much at all. I know that there have been a bunch of people from Google contributing to OpenJDK. The problem with Google is that Google does a little bit of everything, and so it's I kind of don't even try to keep track, because just because some engineer sort of contributes code to some project doesn't mean that it's going anywhere. No, I haven't actually looked at the inner guts of Dalvik. I didn't do it when I was at Sun because, on the advice of lawyers, don't go there. And then, it's been like, nah, I haven't bothered to look at it because there's a lot of other stuff to look at. I sure wish that I know that there had been some conversations between Google and Sun to do something early on. That was all just spectacularly weird in ways that I only ever heard about it secondhand. But it sure felt like something. Some sort of cooperation should have worked out a whole lot smoother than it did. But I wasn't involved in that, and it was weird. And I'll leave it there. Right. So the question was, Sun was preparing to sue Google or Android. Sun wasn't preparing. Sun did an analysis as to whether or not patents were being infringed, and it was like, yeah, but we had decided that we don't like suing people.
That's what I thought, man.
Right. I mean, there was like no point, and most of what they were doing was reasonably positive to the community. even though they'd kind of, done things in a way that we wish had gone differently, but we certainly weren't on a track to sue them. Of course, when we described this to the folks at Oracle, their reaction was, "You fucking idiots." And they see the world through a different lens. Yeah, so the question was about Oracle charging for Java. So I would wager that what's going to happen is that the Java as you know it will continue free forever. If they actually started charging for the base Java platform, they would be so dead so fast. I mean, it would just be horrible, and they know that, right? They know that adoption is really the key thing here. And if they do things to screw up the adoption, then poof, it's badness. But they had this other VM, the JRocket VM. And it had whole bunches of extra stuff for doing, sort of monitoring and measurement on it. And I wouldn't, they seem to be on a path to taking sort of Hotspot and JRocket and sort of swizzling them together. And as near as I can tell, the vast bulk of Hotspot is going to be, carry on kind of forever, because we had a way better garbage collection and way better code generation than JRocket. But they had way better sort of management and monitoring stuff. And so if I was guessing, I would say that when they have talked about charging, it's for the sort of enterprise level managing and monitoring that's like the stuff that they had been charging for in JRocket. I would be shocked if they changed the sort of Java platform as you know it today. Do I see the forking of Java? Unlikely. The forking Java has a bunch of problems. One is you have no idea how much work it is to keep the Java platform running. It's way harder than most of the open source projects out there. Just doing that kind of sort of industrial strength code generator, garbage collector, whatever. It's certainly not a weekend hobby thing. Absolutely not. It's couple of hundred people working full time, and the QA issues around Java are just fierce. Plus which, one of the really big values of Java that seems to be important to everybody in the community is that the platform interoperates everywhere. I mean, it's really quite remarkable how well you can go back and forth between, different flavors of Windows and Linux and OS X. And as soon as you get forks, that starts to disturb that. Forking, just over a nit in the license. I mean, the Apache guys, it's often been difficult to figure out what it is the Apache guys are upset about. Because a lot of the time it feels like it's because, we picked the GPL license instead of the Apache license for the basic source code. Then there's a separate argument about the TCK. Who knows? Oh God! Don't get me started on how the Java mobile world got so fractured. That was really pretty sad. And there were a whole bunch of issues. Some of them are just timing, right? So Java on mobile phones started a decade ago, when the phones were much tinier than they are today, and people were making the weirdest trade-offs. Some of it was because, sort of in retrospect, something that we did that was a real mistake was not doing a binary product ourselves, but having other people do the VMs, and we put all of our effort into testing and these compatibility tests. It's amazing how hard it is to do compatibility just by testing, because a lot of the differences were all over the place. Some of the platforms had different bugs. Some of them had different libraries that they selected. That was often driven by the amount of RAM or ROM that they had on the devices. Some the manufacturers, well, like the earliest folks that were doing Java on cell phones was NTT Docomo, and Docomo, they were hell bent to ship as soon as they could, and they shipped before all the other phone companies had actually agreed on a spec. So the flavor that they shipped with was just different. There were different subsetting, different kinds of QA. When you talk to people that did games, all of the screens were slightly different sizes, and so even though the graphics libraries had ways for you to accommodate the different sizes, people were doing artwork with images, and they would want to have exact pixel registration from their images to the screen, and no two phones had the same screens. And then they would get into really ugly things like none of the screens had color calibration. The sophisticated imaging stuff that's in Java SE about color calibration never got into Java ME, mostly because the phones early on were so small you couldn't afford to do color calibration. So you'd see these game companies, they would reauthor their artwork for every last phone just to tweak the colors because the LCD screens were different. And so that all really sort of exploded. And then, one of my issues with the Android folks is they kind of repeated the same problem, right? They put this bag of source code out there and said, have fun, and have kind of a weak notion of interoperability testing. On the one hand, it's kind of nice to be a peace and love flower child kind of person. On the other hand, the chaos that comes out of that might be good for the people who are making handsets, but they're really awful for the developers on the other side of the fence. And so it's kind of a trade-off between who do you make up unhappy, the developer community or the handset community. And so you look at Apple, right? They have, they're really brutal to the handset world, but they do things pretty well for the developer world. And Android's, fortunately Android started out late enough that it's on most of the handsets that it's on have enough capacity that you can afford to do, an assortment of things that makes sort of mapping from one handset to another work out reasonably well. Things like scalable fonts. But it's enough difference that it's clear that over time it's going to be rocky for them. So I sure wish I could, run the clock backwards and redo Java ME. So the question was about Steve Jobs and deprecating Java for the Macs. That's been, the whole thing about Apple and Java has been pretty funny. They, when that Java deprecated on the Mac thing came out, the first thing that popped into my head was they're about to cancel Xserve. And lo and behold, 2 weeks later, they canceled Xserve. And because you really can't have a server product in anything without a JVM on it. And, Apple is all about control, right? If you wind the clock back like a decade, Apple was desperate to get developers. And so Apple did a really great job with Java on the Mac. But it was always really clear that they hated interoperability. Interoperability is evil in their parlance, right? The thought that somebody could have an app that ran on the Mac and then they could get that same deliciousness on Windows was just unspeakably awful. So in the early days they had done a lot of really nice work to integrate Java in onto the system. These days they're drowning in developers. They don't need another developer community, and what they really want is developers who are tied to them, right? From a business point of view, having developers tied to them so that it's really painful to do an iPhone app and an Android app, or an OS X app and a Windows app. The trendy cool phones are the Apple phones, and actually surprisingly trendy phones are also the Android phones, but the financial proposition seems to work out better in the Apple world, so they've got the sort of economic tilting phenomenon going for them. It's all about control. Do I have any reservations about doing Objective-C coding? That was an educational thing, right? At some point I got to actually get myself a day job. It's unlikely that I'll get myself a day job as an iPad developer, just because I would shoot myself. I spent 20 years writing C code as my day job, and I spent half of that chasing down memory corruption bugs, and I swore to never ever do that again. But that's okay. That's their world. So the question was, do I think Oracle's going to take over the macOS JDK? And that was their press release of like last week or the week before, 2 weeks ago. Because we had, at Sun, we had worked with them to try to take it over, but there were all kinds of issues, and it was mostly things like, to integrate properly into macOS, there were a bunch of secret APIs, and in their integration, there were all these secret APIs, and they wouldn't tell us what they were. We just knew they were there. And then they wanted, it's just sort of like half of their brain wanted to give us the code, half of their brain was like, no, we can't, So, yeah, that was all kind of spastic. How do I compare Scala to Java? Well, Scala is certainly notationally more compact. He did lots of funny little tricks that I would have loved to do, but they look kind of foreign to people whose background is C and C++ coding. The depressing thing for me about Scala is that most people, when they pick up Scala, they don't. So Scala is this sort of two-headed thing. It's partly functional, partly procedural, and most people just pick up Scala and they use it as Java with a more concise syntax, and they don't use any of the functional stuff. And having done gobs of Lisp coding in the deep dark past, I really got addicted to functional coding. And you can do functional coding in Java. It's a style change. It's sort of a stylistic thing that it's actually funny if you write functionally in Java and then show it to a Java programmer. They'll almost always say, "That's awful. Why would you do that?" I'm a big fan of using recursion instead of arrays, and it's like, how do you use recursion instead of arrays? I hear you thinking. But it can be fun. What are the things that excite me and inspire me over the last 6 months? The rally to restore insanity, that inspired me. That was truly inspirational. That was totally worth getting on an airplane for. What do I find inspiring? I guess part of my problem these days is I'm trying to figure out what is inspiring. And the whole friggin' web world kind of feels like, well, it's okay, it's sort of chugging on. And I look at most of these social sites and I sort of go, oh geez, that's all kind of boring. I tend to be most interested in like things that touch the real world. So like a lot of the embedded stuff is a lot of fun, and I've done some helping out in a small way with a Stanford Volkswagen project for the last 8 months. I owe them a whole lot more work, and I owe them a code drop one of these days. And that's certainly been a whole lot of fun. And I don't know, I tend to find myself in sort of odd places. Java ME did extraordinarily well. Not in the US though, right? If you were outside of the US, if you go through Asia and Africa and Europe, you can find, in South America, you can find Java ME code friggin' everywhere. The American phone companies have this walled garden thing going that completely crushed that in North America. Yeah, Spring's pretty popular. I wouldn't say it's more popular than Java EE. I don't know if there are any statistics on it, but I know that Java EE is freakishly popular.
Or JSF versus some of the other web frameworks?
I think part of JSF versus the others is, for me, it's because they're all awful. I hate JSF with a passion. And JSF was done, there are a few things that were done for, I don't know whether they were stupid reasons or it's just the world, the way the world is, right? So Microsoft did this thing called ASF, which was angle brackets and percent signs with basic code, or then later, in between, right? And they go on a marketing campaign saying, this is the greatest thing since sliced bread. They get all the journalists to go, oh, that's the greatest thing since sliced bread. They come to us and they say, ooh, angle brackets and percent signs with code in between. Isn't that the greatest thing since sliced bread? What's your answer to that? And if your answer is, that's stupid. There's a better way to do that. The press, by and large, can't parse your sentences. And so we did JSF as basically a clone to ASF just because it was easier to explain to the press. And then it wouldn't die. Actually, one of my little hacking projects a few months ago was that somebody made some sort of remark to me, and it's like, ugh. I hate JSF, and so I, sort of had a week-long hack attack, and I went, because I've done sort of JSF replacement things like 4 or 5 times, and it's never been any point in releasing any of them because there's like so much other stuff out there, So I did yet another one. And I went, ooh, this feels really good, and it sits on a shelf. I don't know. The next great thing in the tech world, oh geez, I wish I knew.
If you had to guess.
If I had any chance of guessing, I'd probably be a VC with several extra digits on my bank account. I actually have a real history of picking wrong, because I tend to have a fairly geekish sensibility. And one thing that gets proven over and over and over and over and over again is that geeks do not represent popular culture. I don't know. I've really been hyped up kind of forever about things in the world that are intelligent. So like I look at cars and they're getting like incrementally a little bit better. But the way that the electronic systems on these cars are built is Neolithic. It's just horrible. You know, and I've been this project that I've been working on with VW is like right down at the core of the control system for the car. Of, you know, how you actually run the engine and the tires and all of that. And it's like, oh, that's wickedly cool. I mean, I want a car that I can tell it where I want it to go, and it actually just goes there rather than fishtailing all over the place. You know, there's a whole lot of stuff that we could do around things like making vehicles safer and more efficient just by building better control systems. All kinds of things that people could do in like you know, streaming media, for instance, that would be really cool, and people have known that they would be cool for like a really long time, except of course that the movie industry hates them, and well, of course they're kind of coming around, and maybe one of these days Netflix will actually achieve world domination. But actually they're damn near there anyway. You know, so my number one favorite Java project that I think would be just outrageously cool would be to do a US version of the Brazilian healthcare system. Right? I mean they have, you know, what is effectively one giant database in the sky, and they capture every patient caregiver interaction, and, you know, in places where the system is deployed, they do prescriptions as database entries rather than pieces of paper. There's like no drug fraud because they've got enough checks and balances in the system. If you get hit by a car in one place and you go to the hospital in Rio, they can pull up your X-rays from Sao Paulo because it's just all on the net. You know, they do all this stuff with providing health care to the indigenous tribes in the Amazon basin. And, you know, how do you give health care to a people that don't have a permanent address, and they don't even have names, right? They have names, but they're very personal and protected things. So if you ask one of these Amazon basin tribesmen their name, they'll just make something up, right? And they won't make up the same thing twice. So it's like the only healthcare system where name and address are optional fields. And they figured out that really what they don't care about your name and address, right? What they care about is the correspondence between the body and the record. And so that's what they do. And you know, it's just a thing of beauty. I mean, they do things like global scheduling of all their equipment, right? So if you need a CAT scan, in some countries, you know, you end up like queuing up forever. Even in the U.S., you end up queuing up forever. The only reason that the queues are kept low in the U.S. is because we have like way more CAT scan machines than we actually need. But you know, things like you know, all their diagnoses sort of flow into this, you know, sort of like giant bus, and their equivalent of the CDC. It's able to track things like influenza outbreaks, like moment by moment, like you know, their data is like minutes old, not weeks old. You know, so they can respond to stuff a whole lot better. It's just, you know, in some sense, you know, the thing that gets me excited is just stop being stupid. You know, when you look at how these healthcare IT is done in the U.S., it's just stupid, and it's certainly not in the best interests of the patients. You know, the hard problems aren't technical these days, right? I mean, you know, anybody here, I'll bet you just about any person in this room could design, you know, on the back of a napkin, you know, the core of a healthcare IT system that would be way better than we have right now. You know, and the issues are more about, you know, the combination of the social experiment and the industrial politics of it all. OpenWorld has always been about the products and about things that have a non-zero, usually large price tag. Right? Oracle OpenWorld is all about selling. OpenWorld is not a technology conference. It's not a developer education conference, which is what Java 1 always was. And when they sort of took Java 1 and OpenWorld together, it was things just like didn't make any sense, because they were just like so philosophically different. And of course, one of the things that made it difficult is that the Oracle people didn't understand that they were so philosophically different. They couldn't conceive of something that wasn't a non-stop sales opportunity, right? I mean, that's been one of their issues with the Java users groups around the world, right? Oracle has user groups, but the Oracle users groups are all sales opportunities. It's like, no, guys. Top 3 books that every software engineer ought to read. Geez, I don't really know. I mean, the ones that I think of as the really important ones, you probably, the Lisp 1.5 handbook. The Design of an Optimizing Compiler by Bill Wolf. And, anything written by Donald Knuth. And everything written by John Bentley. The whole Programming Perl series. I mean, he sort of stopped writing Programming Perls, but they're still fundamentally great. Of course, fortunately, when I was in college, he was my college algorithms professor. So him in real life is way better than the books, but the books are pretty damn good. But if you're asking for advice on like what's the best Java book out there, I have no idea because I haven't really read any. Social networking. What do I think of social networking? I'm kind of from the wrong quadrant of the Myers-Briggs test to really, it's like, but don't you want to keep up with your friends? Look, guys. A, Facebook friends aren't friends. B, I'm like totally drowning in communication, right? I don't want like more opportunities for communicating. I want more filtering. I want only the good stuff, and my usual, technique has been, wait until some friend comes and beats me up about something, and then I go, oh, okay, that's probably important enough, as opposed to like trying to read as many mind-numbing Twitter feeds as possible. Some of those things, they feel like, there's some great examples of people using them really, really, really well. Like the unrest in Myanmar, for instance. It was just friggin' brilliant. People twittering from concerts, it's like, listen to the music, guys. Why are you doing that? And I had a really funny exchange yesterday with somebody, and because I do something really radical, I turn my cell phone off. It gets to about 5 o'clock, and I turn my cell phone off, and it's like, what? You can do that? Don't? Huh?
Members of the inner party can do that.
Yeah. Of course, part of me is because I'm like deeply jaded on this stuff, right? I mean, I've been using email since the early 70s. So I don't get excited about email. I get the opposite of excited about email. And Facebook is kind of like email with even more noise. The question was about education and software developers. For me, the issue is it feels like once you've started down the road of being a software developer, most people do pretty well. Once the thing that's bugging me these days is, what gets people started down kind of any road educationally. At Sun, one of the things I worked really hard on was supporting projects that did sort of early education in programming. So I worked really hard on funding the Alice project at Carnegie Mellon, and the Blue Jay project, which was at University of Kent and the University of New South Wales and a couple other places. It was a fairly distributed project, to get kids excited. Because this really awful thing happened, a decade ago, right? If you go back, a little bit farther to like sort of the mid-bubble years, kids were going into software like all the time because they saw all these things. Guys like a year out of college and he's a multimillionaire. And if that's your motivation, yeah, that kind of makes me a little uneasy. But then the dot-com bust happened, and all this outsourcing started hitting the press, and it's like enrollment in like every technical field just stopped. And I'd like to go around to high schools and give talks, and it's all like, oh, there are no jobs. Oh, the dot-com bust went, so everybody's broke. The jobs are all in India. And it's like, I don't know whether you noticed, but the number of people on the internet never actually slowed down. Some really stupid companies went out of business, like, shipping big bags of dog food with free shipping. And by and large, the people that died in the dot-com bust, it was kind of an IQ test. And yeah, there are an awful lot of IT jobs got spread around the world, but proportionally not nearly as many as you think. And there are still a lot of tech jobs everywhere. And getting kids to think of any tech field, not just software, as like a valid thing to do, is really hard. What was the motivation in starting Java? The motivation to start in Java was sort of all over the map. We did this project where we were starting to work with, there were a bunch of us who were kind of like upset about the universe, and Scott kind of went and said, why don't you guys go off in the corner and figure out, where there are things that are going on that are weird. We sort of discovered all kinds of things that people were doing with digital systems that were not things that the computer industry was really aware of. So then we started spending time with these folks, and it's like they were reinventing computer science, only really badly. So I'd read these like networking specs where, where the address field in the packets was like 8 bits. It's like, that's going to fail, and you don't understand how to do, like, you don't understand the end-to-end error argument. You don't understand how to do ACKs properly. But on the flip side of it, people from the consumer electronics industry, they had these really strong opinions about things like reliability and evolvability and what were interfaces. And in many ways, the design of Java was sort of saying, to take this sort of list of criteria and then shuffle them according to what you think of as the sort of the consumer, or the not so much the consumer in the sort of consumer electronics sense, but as the world outside of a data center sense, right? So, they really cared about reliability, and it was just like a non-starter to think about trading reliability for performance. And so when you look at Java, there are a bunch of things in there that are all about trying to make it as bulletproof as possible, about trying to make it as secure as possible. And we started this project using C to try to build stuff for the consumer electronics world. And that was mostly kind of an educational thing for us to try to learn how these people thought And then as we were kind of in their like intellectual space, it became clear that the language tools we were using causing way more problems than they were solving. And so my part of that project was to go off and do something that worked in this sort of large scale, long time horizon, sort of consumerish world that dealt with their kind of issues. And that's the only piece of the project that survived. But it was, really the first programming language that was really thought about kind of outside of the box of the computer industry. And that was actually kind of cool. It was really, really useful. Well, right now, there's nothing kind of in the same space as Java, right? I mean, people aren't doing kind of high performance general purpose languages. If Java evaporated, it would be back to C. C and C and C++, and in one specific corner of the world, it would be Objective-C. The .NET CLR versus the JVM. What did they do right or wrong? I used to have strong opinions about it. I guess I don't anymore, other than they sort of deleted all the security features. With their stuff to have to allow unsafe pointers, because they wanted to do C, so it's like, that was like the dumbest thing that they could ever have done. Their instruction set, that they added registers to it, and it turns out that adds nothing. They just wanted to be different. Mostly out of .NET, it was like way more boring when they first announced it than I thought it was going to be. We were like all cranked up because Microsoft might crush us, and it's like, this is lame. They almost like word for word copied the Java manual. And actually, the biggest problem I have with the CLR is that they haven't put nearly as much energy into it. I mean, I haven't seen like benchmarks from like the last year, but benchmarks from like 2 years ago. And it's really kind of hard to get really comparable benchmarks between the JVM and the CLR, but we were running like at least a factor of 2 on almost everything, because their code generators just weren't very good, and it seemed like mostly because they were being lazy. I mean, as near as I can tell, Microsoft in their heart of hearts doesn't care about the CLR that much, because all their real meat and potatoes projects are not that, right? Word and such are still fundamentally big bags of C code. So they haven't really had to depend on it for their own products. And it hasn't felt like they've done all the rocket science stuff underneath that they could have done. But like I said, I have no like really recent data. But working for Oracle is a really big one. Confusing prototyping with engineering tends to be a big one. People slap things together to build a prototype, and then they go, "Ooh, now we got to deploy it." Like, no, a prototype is a learning experience. You hit the delete button, and then you rewrite it. I'm a big believer in deleting. There's also kinds of things about like performance engineering. So I tend to be a performance nut. There's this sort of general principle that early optimization is a bad idea. I tend to over-optimize early. Most people, they kind of think about their data structures almost last, and it's like, I want to write some code. It's like, well, no, think about the structure of things. Think about the data. It's object-oriented programming because you should think of your data first, or the objects first, how they interconnect. And a big piece of that is, how things like indexing structures work, how things connect. There's a huge difference between an O(n) algorithm and an O(n) squared algorithm, and it's really easy to accidentally do n squared instead of n, and it's usually just a difference in the way you did your data structures, and so a premature optimization can be evil, but then again, just doing the stupid obvious thing. One of the problems with the way that people often do their data structures is that they do kind of the stupid obvious thing, and then 10,000 lines of code later, you can't actually fix it because everything depends on the kind of the lame way you did the data structures. Lots of people don't think about stuff early enough. And there's also there's sort of a crowd there that believes that like UML modeling qualifies as thinking. I like UML modeling, but that's different than really sort of thinking about what you're doing. I actually like to think about what I'm doing before I do it. And what feature do I regret that's in Java? I don't know. There's some there's some that I somewhat regret, like XOR. Why is that there? When did any of you ever use XOR? But then there were things that were kind of that I ripped out that were sort of halfway there. Like there was a proper assertion facility with preconditions and postconditions. There was operator overloading for a while, and that went away. But that was mostly because, I had all these C++ programmers who had been burned by operator overloading. And it's like, no, if operator overloading is there, then somebody will try to do output with the shift operators. And, that's just evil. That is actually the work of the devil. The last, wow, why didn't I think of that? Oh, probably Fruit Ninja. I don't know. Somebody showed that to me a week ago, and I went, A, this is really, really lame. B, this is actually pretty damn compelling. But most games kind of have that sort of feature. Yeah, I'm certainly Oracle's piece of work. Don't go there. Google's a good place. They've gotten pretty big. And I sort of feel like I've sort of done the big thing. In the social media world, things like Facebook. I wouldn't say that Facebook is bad. It's just not me. I'm like I said, the wrong sort of social type to really think of Facebook as cool. And a bunch of the people in the social media world have had really hard time with issues around privacy, and I think that's partly an issue with the companies and partly an issue with sort of society in general to try to figure out what is actually appropriate. The most reasonable of the social media companies is probably LinkedIn. They've actually been incredibly careful about sort of privacy in that, but then they do a very focused kind of social media. And I guess some of the stuff I get kind of jaded about because it's like so many people doing kind of same things, right? So like there's hundreds of companies doing cloud something, and the VCs are funding cloud anything. There's some people who are doing pretty interesting twists on cloud that I kind of like, but where that's going to go is sort of hard to tell. On average, I'm a believer in cloud as a concept, but who are going to be the winners and losers? I have no idea. I think I'm if I had to say I'm jaded, it's sort of about the fact that the people's attention is like so focused on the web, and it feels to me like that's like, 10% of the computing landscape. If you look at what goes on in, say, biology, huge computational problems in biology. The people who do, protein folding up in South San Francisco, which is kind of everybody there. That stuff is really, really cool. It sure doesn't show up on anybody's cool radar. But, if they can, all modern medicine research, it's computers. Right, it's computing, and none of that has any magic pixie dust coolness on it, and modern materials. It's again all computer simulation and all the rest of that, and the computing behind that. It's like, so most people don't even think of that as computing because it's something that like a scientist does. But you talk to most people in physics. They spend most of their time writing code, not doing physics experiments. And it's just a cool world filled with thousands and thousands of different things, and it always felt to me like the web is kind of like a corner of it. But then, I spend a bunch of time, getting myself an invitation to go crawl the tunnels at CERN before they turned it on, because I thought that was incredibly cool. And it was incredibly cool. But then I'm kind of a twisted and silly person, so. I haven't looked at that much at all. I have looked at the Vista system. Vista's kind of a weird thing. It was a healthcare IT system that was done by the Veterans Administration. And then it was extracted from the federal government through a Freedom of Information Act thing. So it's now this open source healthcare IT system. And now the VA is kind of re-engaging with them. And that has a chance of being on a sort of an interesting vector. The problem is it's all written in this programming language called mumps. And I don't know if any of you have ever looked at a mumps manual, but it is amusing. And so, yeah, I don't know. But, some of the stuff, the state stuff, and the interchanges, but the problem with all of the things that are kind of like interchanges is that they never, it's really hard to get people to sit down and actually decide on like what the schemas really are. So they end up, the interchanges are all about mapping one schema to another. And most of the schema mapping ends up losing something somewhere. And many of the hard questions are things like, what are procedure codes in operations? And yeah, the AMA has sort of standardized procedure codes, but then there's all sorts of corner cases in the procedure codes that are not standardized. And how do you make those things work? What's a standardized street address? It gets messy pretty fast. And I mean, the Brazilian system isn't especially brilliant. I mean, they were very competent people, but they had the advantage that they had nothing, and they just got to decide, this is what an address looks like, this is what and then they didn't have to worry about interoperability with anything. And their healthcare system is it's one where all the hospitals in that are independent companies or private. It's a single payer insurance system, and so the hospitals can run any healthcare IT system they want, and they can buy it from whatever healthcare IT system they want to, or they can use the one that this consortium of universities did for free. And oh, by the way, you have to use that system if you want to get paid from the insurance company. So none of the commercial systems have much success. Thank you. My jaw is totally killing me. Thanks.